So now we are most definitely heading to question number 1.2. Now let's see what does 1.2 want from us. Now 1.2, it says to us, now assume that the pressure changes along the bed mass. So now we have variable pressure along the bed mass. What would be the required bed mass of iron or nickel catalyst to achieve 40% conversion? So now these questions are most definitely the same. The thing is, now we have, the only thing that we're gonna change, it's a small thing, because now, and by the way, the answer won't be far fetched from this answer that we see over here. The answer will be very close to this, because the pressure has small effect at this point in time. Do you understand? So for 1.1, we had the constant pressure, but here we have a variable pressure, and that variable pressure, it will have a slight effect on our mass of the catalyst. Do you understand what I'm saying? The answer should be the same, but yeah, should be the same, but we're gonna have a small slight value on it. Okay. Now let's do it. Now, since the pressure, the only part that, okay, let me just take it from here, 1.2. I'll take it from a, remember 1.1, we have already derived the design equation, so I will take it from there. Okay, I will take it from the derived design equation. So from the question above, from question 1.1, I think that was equation 4. Equation 4 for general mole balance equation. Look at the equation number 4. What you're gonna do is, which is dFA over dW is equals to RA opposed to pi over there. Ne? So from this equation, this is the general mole balance equation. And then the second equation, which this is GMBE, right? Then rate law, still do have the second order. It's going to be negative RA is equals to K, CA, CB, or it can be CA squared. Does not matter. I told you that the concentration of A and B are equal, so it really does not matter at all. And then stoichiometry, now this is where things are going to be a little bit different. Smaller than thing, we're going to change it here. Stoichiometry. We're gonna have, okay, we know this. It's gonna be the same as negative FAO. Dx already derived as well. What else? Concentration of A. Now, concentration of A and B, by the way, let me just say it's gonna be the same for the sake of how I wrote it over there. Now, it's gonna be like this. It's gonna be, I'm not gonna explain this deep. I explained it on 1.1. If maybe you just jumped 1.1.1, please quickly go to it before you come to this video. CAO 1 minus XA. Okay. But now here, okay, in fact, let me just explain it, because you might even get lost. You guys, I know you might even not understand where is this coming from. I love deriving this when I explain it, because you won't understand it. So recall that I said this will look like this, right? We know the stoichiometric equation of how to calculate the concentration. And then we said FA, we introducing the conversion factor. It's going to be FAO 1 minus X of A. Then now let's talk about this guy. Said to you, the volumetric flow rate will be affected by pressure. This won't be the same as this, because this will be affected by pressure. The initial volumetric flow rate will be affected by 1 plus epsilon X of A multiplied by P sub naught divided by P multiplied by T over T sub naught. Isothermal this, we cancel it off. But now 1.2, we do have variable pressure. The pressure changes. So this, it is not equals to 1. It's not 1 divided by 1. It's not the same. So we're going to keep it. Do you understand? So that means now what we're going to have is the volumetric flow rate, 1 plus epsilon multiplied by XA. We have P naught divided by P. And then remember this guy over here, it will give us concentration of OA. And then recall I told you that the epsilon will be 0. It will affect the whole thing. This will be 1. But what about P? 1 minus XA. So instead of me writing it as P naught over P at the bottom of my fraction, then I'll have to interchange the numerator and then denominator as math. Then it's going to be P divided by P sub naught. Okay, now here's the only difference by introducing P over P sub naught, because the pressure, it is definitely changing. And then from here, what then are we going to do? It's simple. Combine the equations. Step number 4, combine all of these equations. So if we combine them and then try to, so me, I'm going to take it from here, ne? Just to avoid confusing you. I'm going to take it from here. I'm not going to take it from here. I'm just going to write it like this. Okay, that's what I'm going to do. You will combine it, you will see. Combine this, combine with this to this. Okay, combine all of those. You'll get something like this. W is equals to FAO divide by K CAO squared XA divided by 1 minus X of A P over P sub naught. 1.1 and 1.2 are exactly the same. The thing is, we just have to add this. You understand what I'm saying? What I did in 1.1, it's the same thing. It's just that the difference was under stoichiometry when I was deriving the expression for concentration of A, where the pressure now, it is no longer constant, it is changing. So, but now from our data sheet, we can see that P sub naught is equals to how much? Let me write it here. We have W is equals to FAO divided by K, CAO squared, X of A divided by 1 minus X of A. Told you how to derive this, integrate this, sorry. Then this, remember, oh, by the way, I think there's something that I didn't write here, supposed to be squared, squared, and this will be also squared, ne? Not here, sorry. Oh, I'm confusing you. I'm really confusing you. Not here, not here. We'll square it where? Let me show you. Remember, okay, by the way, even this will be the same as CP. Let me just put it out there. So when you substitute this over here, you substitute this over there, you multiply them together. That will give you squared, will give you squared, will give you squared, okay? So this will also give you squared. I apologize for that. Yeah, so now here we have this P over P sub naught squared, that will be equivalent to 1 minus alpha multiplied by W. Now, again, we change this. We are not yet here. In fact, let me fix this because I'm jumping too much. I want to show you how to derive this, to integrate these things, okay? It's because I just wanted to do this thing quickly. I'm sorry about that. Now, okay, let me just combine them so that you can see. We're gonna have dw. I wasn't supposed to get rid of this because now I will derive this based on, you will see, dw, ne? Basically, I'm gonna take it from here, show you. I'm gonna take it from here. Okay, or I can even take it from here. Yeah, I was supposed to take it from there. So we're gonna have dw, okay? Let me just do it step by step. We have negative, I'm substituting FOA, dxa divided by dw is equals to the rate. There I'm gonna have K. I'm gonna have CAO 1 minus XA, that is CA, and then CB. It's gonna be the same thing again. So to avoid wasting time, let me just square it because you can even see I just want to write everything quick. Let me just square it. P sub naught. Let me just square it for the sake of time. Okay. When you multiply CA and CB, you will get this because I told you that CA is the same as BCB. So you're going to substitute the same expression over here and then multiply them together. It will definitely give you this, okay? Right. And then from here, separable, I'm going to substitute P sub naught. So I'm going to have dW, right? Cross multiplying with this, I'm going to have PW. Then what is P? What is this? P over P sub naught to the power of 2. It's 1 minus alpha W is equals to. And then on this side, I'm going to have this guy. I'm going to have this guy divide by everything except this, maths. And I have FAO dxa divide by, okay, divide by K CAO squared 1 minus XA squared. Okay, yeah. So this is the new part that we didn't have from 1.1. And then I will integrate then 1 minus alpha, this dw. And then this side, I have FAO divided by K, CAO squared, integral of 1 over 1 minus XA squared dxa squared from 0 to XA. 0 to W. So now this, I told you how to integrate this again from 1.1. Okay. And then this one, how to integrate it, it's simple. Invite W there. Invite is going to be squared, divide by 2. So we're going to have 1 over 2 alpha W squared. This is how we integrate this. And then this side is the same as what I showed you. So we're going to have FAO KCAO squared XA divided by 1 minus XA. And yeah, that's it. So we have already got this 1.1. We said that, which is this, is equals to 0.08. So here we have 0.08. And then this side, we have 1 minus 1 over 2. And then our value of alpha, it's given to be that value, which is how many zeros? Let me see. 1, 2, 3, 4. 0.1234 1 W squared. Then how to solve this? You see, this value is very small, so it's close to 0. It can affect the whole thing. So our W could be the same as 0.08. But then if you want to use your quadratic formula like that's what I say, this pressure doesn't affect unless if this value was high, was greater, per kg was greater. So now in this case, what you're gonna do is you can use your this negative W squared, the answer there 0.5 multiplied by 0.12341. That will give you, that will give us negative 5 times 10 to the power of negative 6 W squared plus W minus 0.08 is equals to 0. So we can use our quadratic equation formula. Our B in this case is 1 plus or minus square root of our B, it's 1 squared minus 4a, our a is negative 5 times 10 to the power of negative 6. For AC, it's negative 0.08, perfect. Divide by 2a, 2a, where are you? A, it's negative 5 times 10 to the power of negative 6. It's 2a, right? Yeah, it's 2a. Then let's punch this on our calculators. Negative 1, negative 1, negative 1 plus square root of 1 minus, okay, everything's gonna be, okay, it's fine. 4, negative 5 times 10 to the power negative 6, negative 0.08, divided by 2, multiplied by negative 5, times 10 to the power negative 6. Let me see if I did a mistake there. 1, it's negative 1. See, the answer doesn't make sense. 1 minus, yeah, 4, negative 5 times 10, negative 6, multiplied by negative 0.08, divide by 2, multiplied by negative 5 times 10 to the power negative 6. Let's see then. I get my first W, I get 0.08000000 until 321, you know. So you see how this values, it is the same as this one. It is the same, the answer is the same as this one, but it is affected a little bit. And then when you get the negative 1 for sure there, we'll get how much? We'll get a very high value, 19999.92. Okay, that's a very high value. So kg per kilo per catalyst, catalyst, not per catalyst, kg catalyst, and therefore the answer will be this one. Okay, so that's 1.2. If you don't understand, feel free to comment under the comment section below. I'll most definitely attend to that. Thank you.